which is on the patch crop experiment. That's how we call this. The nature of this presentation is slightly different than what you perhaps are used to. I will pretty much focus on describing an experiment, although I will give some background information regarding the concept of sustainable crop production, regarding the idea of diversification. Terms like scales come up, the link to experimental work. The right icons sort of indicate the triangle of the key, let's say, perspectives that I would take in that presentation. I will make a link to digitalization, new digital technologies as we develop them in Phenorob, and to which extent we have a link here to the patch crop experiment and some of the opportunities that we see in that link. So the notion of sustainable crop production we have also addressed in our proposal, and it's pretty much the main ambition of the Phenorob cluster of excellence to contribute to sustainable crop production. And the perspective that we have taken so far is pretty much summarized in this figure, which we have also used in our defense talk, but also on other occasions, which shows that the crop yields that we aim to further increase in order to satisfy future demands, we would like to produce within reduced inputs of resources related to fertilizers, but also related to chemicals and other inputs. And we think that we can achieve that, we have the ambition to achieve that by the development and use of digital technologies that help us to better understand plants and soil and integrate that understanding into larger systems. That's all fine, and we can also sort of graph that differently. This is the same what I've just said in a different, or put in a relationship between the yield response to resource input. With this curve, I want to make the give the information that that relationship is not linear, has some implication of how we have to approach the problem. But what we've basically trying is through the use of new technologies, for instance, by being more precise in the application of our resources, to have a shift of that curve. We call this also the yield response frontier line, have a shift in this curve towards high yields with the same amount of resource input, or perhaps in some occasions also the same yield, but then with less resource input, or maybe even both in combination. So that is, I will come back to that graph, therefore I've introduced that here. There is also a definition by the FAO of, or I put that differently, the whole idea of sustainable crop production is approached from different concepts. And one of the most prominent concept is called sustainable intensification, or sustainable crop production intensification. And a definition is provided here by the FAO, which in the first line or first sentence picks up on what I've just said. Sustainable crop production intensification aims to produce more from the same area or the same amount of resources put into the production. But it also says, while reducing negative environmental impacts, conserving natural resources, enhancing healthy ecosystem services. Eventually, there's also a link to biodiversity, not in that definition, but also in related definition. It also makes a relationship to eco-friendly approaches to farming and combining traditional knowledge and technological advances. These aspects are not to ignore, because there is a large farming community and a large research community that adopts that definition. There are other concepts to that which are becoming more and more prominent. And I have sort of used that chart here because that gives a nice overview of how they are related, at least in general terms. So sustainable intensification, I just gave you a definition. There's also the concept of ecological intensification and agroecology. Organic agriculture is perhaps known to most of you. The other two terms gain increasing awareness. And there are sort of approaches that try to utilize more on the ecological processes and relationships that occur in the environment, in our ecosystems, and make use of these processes. To which extent that is successful, I will come back to that. I'm introducing this because we cannot ignore this. This is part of how sustainable crop production is being seen at the moment and will most certainly be seen in the future. So as far as agroecology is concerned, it is certainly a scientific field, but not only, it is also a practice. And I'm saying that because there are a range of approaches to that. Very site-specific, farming-specific approaches across the world, but also across Europe and increasingly also in Germany. And it is also a social movement. That is also not to ignore, particularly when it comes to the adoption of new technologies. We have to be aware of those things. Not very much relevant to most of your work, but at the more, let's say, coordinating level, that's something that we should have in our view as well. There's another aspect to that, and that refers to the scale of sustainable crop production. When we focus mainly on the plot and field scale, we should be aware that there are other levels of the organizations that also need to be considered when we talk about sustainable crop production. The farm level, but also the landscape and perhaps also the sector level. But certainly the landscape level is important, particularly when it comes to aspects related to ecosystem services, not only to yield, but also to other ecosystem services and biodiversity. Certain indicators of biodiversity you cannot sort of affect or improve by just looking at field or subfield scales. You pretty much ignore relationships that can only take part at the larger level of the organization. If I come back to this graph here, we think that at the plot scale, field scale, there is much to gain in order to improve resource use efficiency, but also at the next higher level of the organization, the landscape, there is an additional benefit by thinking of how we arrange fields in a landscape context. That could be one way. There are other ways, perhaps introducing landscape structures, heterogeneities in a different way. But already by the idea of thinking of how you arrange fields according to the resource situation in the landscape, you may gain another benefit in yield with respect to the reduction of resources that are required in order to produce the same amount or perhaps even more yield. I'm coming back to this point of the ecosystem services and the biodiversity. This is a general sketch of what people have thought some years ago of how landscape complexity could affect ecosystem services related to provisional services, for instance, like pollinator biodiversity or natural enemy biodiversity, pest abundance. How this could then affect pollination, how this could affect pest control. And eventually there may be a feedback effect also on yield, because we have this effect on pollinator biodiversity, on pollination, we may have a feedback effect on yield. There has been very little evidence so far, experimental evidence so far on these relationships, but in recent years we see increasing evidence from studies, and I have included some of these studies here just for you to get an update that there is some increasing evidence becoming available. This is a study, a meta-analysis of different data sets that studies to which extent landscape simplification affects species richness, this is the upper part here, and perhaps evenness. If we see the effect of simplification on species richness, we see that that effect is negative. So it's pretty much in line of what you have seen before. There's a positive effect on pollination and a positive effect on production. So once we are able to increase richness, we would increase pollination. And we see, at least from these data, some effect on production. So initial data here becoming available that show that those effects are in fact really measured. Other studies have compared different, let's say, production systems, and that's a study that compared monoculture cropping systems with mixed cultivated crop rangeland landscape cropping systems in landscapes, and they have assessed that considering a range of different ecosystem services and biodiversity indicators. And you can see already visually, that's a nice visual representation of how these different systems compare. So with those sort of information, you're really able more comprehensively to say what the change in the system that you cause because you introduce new technology really do to ecosystem services and biodiversity. And you can compare different production systems and also different landscapes. There is a range of practices, and that's important for us because we talk about management, we talk about intervention. There's a range of practices that you can consider when you talk about diversification measures. And some of them are listed here. I'm not going into the detail. The essence I want to point out here is that in the combination of these different diversification practices, also this study shows a positive effect on different ecosystem services, but also on yield. Here on crop yield, but also on soil fertility, nutrient cycling, carbon sequestration, etc. There are also some negative effects, but in general, these effects are positive as this green color suggests. Coming back to the point to which extent these effects on the ecosystem services really have a relationship with an increasing yield, that's also studied here and shown in this graph by the upper right quadrant. The win-win relationship points to a positive relationship in the way that the ecosystem services that have been positively affected by the diversification of management practices, in fact, also have a positive yield response. And those sort of studies are very interesting to see, and there are sort of have been a justification also for us to pursue with the idea of initiating or setting up a landscape experiment in which we explicitly want to study diversification. In general, the number of studies on crop diversification have increased over the years. I've said that already with respect to the spatial different diversification, but also with respect to temporal diversification. However, if you look more closely into that, we found that the studies that are really based on experiments only make up a proportion, perhaps not even half of the entire number of studies that we could find in the literature. And that varies very strongly depending on the diversification measure that we are looking at. These are mainly referring to crops and cropping systems. There's even less or much less when it comes to the landscape level. Apparently, there is a challenge to set up those experiments, and there's also a challenge in generalizing from these experiments because there are very site-specific conditions that come into play, and these experiments are very multifactorial and difficult to set up and to gain general information out of those experiments. Because the whole concept of diversification is not new, but it is very diverse in what people actually understand under diversification. There are some attempts to classify, to develop classifications along the different dimensions for which you can diversify with respect to the spatial scale, or you can change field size, you can change field shapes with respect to the temporal scale, or the sequence of the crops, crop rotation, multi-cropping, but also with respect to they call it here genetic, you may also call it compositional, or which crops do you have or which varieties which you have in your diversification approach, and also the configurational, which patterns do you actually want to investigate, the shapes of the fields, etc., whether or not you use border plants, etc. And you can already see, and that's on the right-hand side of this graph, that there is in that multi-dimensional space, there are a range of possibilities to diversify, which makes the experimental investigation difficult, and also any generalization from that. Things become even more complex if you really want to move from the field to the landscape scale. There are quotes that people say, well, obtaining experimental evidence using real landscape is usually impossible. We know that as we move up the levels of the organization, our ability to control experimental factors becomes much less. And as we move up the levels of the organization, we're also aware of that. We know that the importance of modeling and perhaps other ways of analyzing and using data becomes more important. So the part of the virtual experimentation in conjunction with the practical experimentation is increasingly important as we move up the scale. And that's also one reason why we, in that landscape experiment, have also several modeling activities closely related to that. Coming back to phenorob, we think that if we really want to make that link to the level of the ecosystem services biodiversity and assessing those in the context of sustainable crop production systems, there is also a possibility and opportunity to include this landscape level and the concept of the field arrangements in order to also have that link considered in our cluster. To some extent we have that, and with this experiment I think we can greatly contribute to that. Let's maybe even say gap, in order to make the link really from the field to the landscape level with respect to the ecosystem service biodiversity indicators. Now there is a research gap, I mentioned that, and there are challenges in setting up a landscape experimental platform to measure processes and indicators to understand and design sustainable cropping systems using new digital technologies. And there's a set of ambitions related to that. This platform should be set up in a landscape context, and it should use an integrated systems approach. It should have a reference right from the beginning to an integrated systems approach. It should integrate comprehensive measurement and monitoring data, because only then you are able to make that multifunctional assessment. And it should develop integrated modeling approaches. With respect to the platform, the value in such a platform is particularly evident if you are able to have a continuous experimental research. So a platform for 1 year or 2 years doesn't make any sense. The longer you can establish it, the more valuable and better the data will be for the research activities, but also for other activities. There's a clearly demand for an interdisciplinary approach, and you need robust monitoring approaches in order to really gain from such a setup. And there's also an element of reach out activities. And that's the third ambition, there's also part of co-design and co-innovation, because these type of experiment you cannot do without the practitioners, the farmers that are working in the landscape context. I will come back to that in one of my following slides. So that co-innovation and co-design aspect is not to ignore. It also comes back to the agroecology definition that I gave before, the element of the practice that comes in here as well. Okay, so in terms of landscape experiments, there are also, you also find in the literature some attempts to develop, where people have developed a classification. And the experiment that we have set up, the patch crop experiment, would fall into a group which is called identification of process sensitivity to landscape structure. So there is a classification, and we find ourselves back in that classification, particularly by looking at processes related to not only yield, but also to other ecosystem services and biodiversity. This is an image that you have already seen. We have set up that experiment last year. by testing the effects of new field arrangements, in particular the effect of crop diversification in combination with new field arrangements, hypothesizing that this is an effect on positive effect on resource use and resource use efficiency, on ecosystem services and biodiversity. We have identified an area near Berlin, near ZALF actually, which is an area to which we have access to several farmers and total area of about 10,000 hectares, of which we sort of identified in the first step as a farm which could provide an area of 400 hectares. These 400 hectares, that's basically the landscape experiment. And the core part of that is the patch crop experiment. And the patch crop experiment has 70 hectares, and it has several plots in these 70 hectares that represent different crop rotations and different crops in these crop rotations. In total, 9 crops. A patch has a site of half a hectare. And we have set up this experiment in order to anticipate differences in this 70 hectare field with respect to elevation, but also with respect to, particularly with respect to soil conditions. And that is shown on the following slides. I could stop here, where we sort of arrange these patches according to the soil conditions for which we had information, but also considering the yield that have been obtained in the past. So there has been a relatively complex analysis of data to identify high yielding and low yielding zones. And that has been the basis in order to allocate the 2 crop rotations, which you see here, and the different crops in the crop rotations were then chosen for being a more high yielding or more low yielding, potential low yielding crop. There are other factors that we test, how the patch size. We also have these patches sort of mirrored in real fields, still in large fields. And we have the factor of diversification. I explained that already. We also have a factor on land use intensity, where we have replicated the rotations that we sort of run under conventional farming by a treatment with reduced pesticide use in these 70 hectares, but also in the surrounding fields. And we have introduced structural elements like flower strips here in order to see whether there's a benefit by these additional structural units on perhaps the reduction of pesticide use, etc. So the objectives of these experiments are to, on the one hand, to improve the resilience of production systems. So we hypothesize that through this approach we can do that. To promote biodiversity ecosystem service provision, to minimize the use of chemical synthetic pesticides, and also to reduce the long-term use of, or the rates of mineral fertilizers, and use automated sensor controlled technologies for this. One example to this factor which I showed here, the factor in which we try to understand the effect of reducing land use intensity with respect to pesticide use, that is something that you can almost not set up without a farmer. There are so many ways of reducing the use of pesticides. We talk about herbicides, or we talk about insecticides, fungicides. Do we talk about timing? Do we talk about mounds, etc.? There are several combinations of ways of reducing that, and there is a fair amount of let's say, local site-specific knowledge, and also knowledge about the available technology necessary in order to design and implement such a treatment. So it's not trivial. And I'm making that point because it's different to our way of how we perform experiment and how I did perform experiment in the past. It really requires an engagement of a farmer here. These are some impressions of the experiment from the last year, not going into the details here of that. I want to spend a few minutes on the measurements that we have performed, that we have set up. And as you can see, we try to address different different parts of the system related to agronomy, crop science, related to soil science, related to ecology, to crop protection, and also to understand and monitor the operational management data. So there's a range of management already taking place, and this is gradually increasing for the plot and the patch sizes, but also for the field and the landscape level measuring and monitoring activities. And the more we monitor and measure, the better is the databases in order to do a more comprehensive analysis and then also more comprehensive assessment. From the first year, we have a range of results already that became available, and I will not go into this. I'm not showing any results today. We have had organized a specific workshop where we exchanged on these first results. Very interesting and already surprising results in the first year. And I think we are in a good situation to be lucky that we could establish that experiment so successfully in the first year, to have a good basis also for the following years. And the results of the first year are very, very promising in that regard. Some impressions of what is set up in this experiment. I've listed that. These are just some images, but it shows the span of measurement related to soil processes up to biodiversity measurements, even up to bird monitoring activities that we carry out in the experiment. Some of the engagement of users and third-party funded projects. So that experiment is set up by ZALF in conjunction with FENOROB. And I want to acknowledge here my colleague Katrin Graman, who has spent a great deal of work and spending great time as well on coordinating the experiment. And as far as FENOROB is concerned, we have a close link to core project 5, new field arrangements. I want to mention here Ixchel as well. She takes care of the modeling work using the SimPlace modeling framework that we have developed in our group in Bonn. But there are increasing links also to other CPs, and that's very good to see. We also have a link to other projects. I want to mention here the Darkest project, and to other partners, and also that is gradually increasing. As far as other projects are concerned, we at ZALF have funded 2 other projects, size of 1 million euros for both projects, on cropping system diversification and on upscaling N dynamics and N losses. And we're preparing a 3rd call this year in order to substantiate the research activities as well. But the whole platform is open for further engagement. So it lives really from the engagement. The more people we engage in that, the more valuable the data anyone takes will become, because the value is really in the integrated use of the data and production of the data that you produce. The projects that I've mentioned here, I've given some more information. I'm not going into the details of that. For someone who is interested, there are also the names if you want to contact these people with respect to the 2 topics. I would like to give towards the end of my presentation an outlook of where we want to go and where we see the link to the FENOROB technologies. So I stressed that already, I'd like to repeat that here. I think there's a high value for the integrated monitoring and modeling, particularly with regard to the assessment of the effect of management and also new technologies on ecosystem services and biodiversity. There's also some value in evaluating patch crop and FENOROB relevant digital technologies for smart interventions. We also see that as a platform for engagement with other farmers. Farmers in the area are already showing interest in these activities. That is important for the upscaling and also important for the adoption of anything we do there, also with respect to new technologies. And it is a platform for further experimental studies. So as for this first point, integration of monitoring modeling, we think that really through this bridge here with the new field arrangement, we have an angle, we have a link to be able eventually to provide some at least demonstration cases of how we be able to assess implications on ecosystem services biodiversity. Well, we gather a lot of data. With this data in combination with modeling, we will be able to show and demonstrate how these different technologies affect our production systems, and which production system, which interventions are most promising in the context of sustainable crop production. And we have in the experiment, we have a great demand for really practical application of these new technologies. So I only want to repeat that again. If there is an interest out of FENOROP in sort of practical application, practical testing, evaluation of some of the devices that are being developed, we would be very happy to provide the necessary conditions in order to do that. Along this line, we are organizing a workshop. We call this Field Robotics Workshop. That's coming up pretty soon, 5th of May. We unfortunately will have to have that virtually, although there will be some demonstration activities in the field filmed and shown in the virtual workshop, so that we try to at least have some link, even though it's a virtual link, to the practical application of some of the new technologies. And with this, I'm through my presentation. I thank you very much for your attention. Thank you.
Yeah.